Hi there and welcome to the Probability and Statistics Final Exam Review. What we're going to go over in this video are problems from the practice final and work through the solutions. According to a scientific journal, an important property of fiber is its water absorbency. A random sample of 20 pieces of cotton fiber was taken and the absorbency on each piece was measured. And the data are in this table here. Compute the sample mean. So in order to do that, we know that we have 20 values. That means that we add up all the numbers and then divide by 20. When we do this, we get a sample mean of 20.78. In a study conducted by the Mechanical Engineering Department at a university, the steel rods supplied by two different companies were compared. 10 sample springs were made out of the steel rods supplied by each company, and a measure of flexibility was recorded for each. The mean for Company A is 7.87, and the mean for Company B is 10.32. The variance for Company A is 0.8712, and the variance for Company B is 0.3196. Does there appear to be a difference in flexibility between the two companies? Well, in order to answer that, we have to compare the sample means and the sample variances. Notice that Company A's sample mean is smaller than Company B's, and Company A's sample variance is greater than Company B's. So there does indeed appear to be a difference in flexibility. A tire manufacturer wants to determine the inner diameter of a certain grade of tire, and we have the data here. What is the sample median? In order to determine the sample median, we have to order these from least to greatest. When we do that, we get this list. Since there are 8 numbers, or in particular the even number, we have to take an average of the middle two values. We get 569 plus 570 divided by 2, which is 569.5. The probability that an industry will locate in City A is 0.7. The probability that it will locate in City B is 0.4, and the probability that it will locate in either A or B is both is 0.9. What's the probability that the industry will locate in both cities? So we'll let A be the event the industry locates in City A, and B be the event that the industry locates in City B. Based on the information given, we have the probability of A is 0.7, the probability of B is 0.4, and the probability of A union B is 0.9. Now remember from the formula of the probability of A union B, this is the probability of A plus the probability of B minus the probability of A intersect B. The piece that we're interested in is the probability of A intersect B. So plugging in the values that we know and then solving for that, we get 0.2. A random sample of adults are classified by sex and level of education, and we have the data in this table. A person is selected at random from this group. What is the probability that that person does not have a college degree, given that the person is female? Because we know the person is female, we only have to look at that column. There are 275 females, and of those, 225 do not have a college degree. So we simply look at the ratio of that, simplify the fraction, and we get 9/11ths for the probability. The probability that a married man watches a certain television show is 0.3. The probability that a married woman watches the show is 0.4. The probability that a man watches the show given that his wife does is 0.7. Find the probability at least one member of a married couple watches the show. We'll let H be the event the husband watches the show, and W be the event the wife watches the show. The probability of H is 0.3, the probability of W is 0.4, and the probability of H given W is 0.7. Now remember, the formula for the conditional probability of H given W is the probability of H intersect W divided by the probability of W. What we want to know is the probability of H union W. And the only piece of that we don't have is the probability of H intersect W. Going back to our conditional probability, we can use what we know to find the probability of H intersect W. And from that we see that that's equal to 0.21. Now we have everything we know to find the probability of H union W, which is 0.49. According to a recent report, 40% of new businesses in 2013 were started by women. In 2013, 10% of new businesses started by women had revenues of 50 grand and above, whereas 17% of new businesses started by men had revenues of 50 grand and above. A new business started in 2013 is selected at random. It has revenue of at least 50 grand. What's the probability that that business was started by a woman? We'll let A be the event that a new business had revenues of 50 grand and above, and B1 be the event that new business was started by a woman, B2 the event the business was started by a man. Using Bayes' formula, we're going to find the probability of B1 given A. Probability of B1 is 0.4, so the probability of B2 is the complement of that, or 0.6. The probability of A given B1 is 0.10, and probability of A given B2 is 0.17. So now all we do is plug into the formula, and we get that the probability of B1 given A is 0.282. The total number of hours measured in units of 100 hours that a family runs a vacuum cleaner over a period of 1 year is a continuous random variable that has the density function shown here. Find the probability that over a period of 1 year, a family runs their vacuum cleaner less than 115 hours. First, notice that x is measured in hundreds of hours. So 115 hours corresponds to x equal 1.15. This is continuous, so we're going to find the integral from 0 to 1.15 of f of x dx. Because this is a piecewise function, we split it into two pieces. The first piece is the integral from 0 to 1 of x dx. The second is the integral from 1 to 1.5 of 2 minus x dx. When we integrate these, we get x squared over 2 from 0 to 1, 2x minus x squared over 2 from 1.15, or from 1 to 1.15. Calculating this out, we get a probability of 0.639. Suppose the joint probability distribution of x and y is given by f of xy is x plus y over 126. X takes on the values 4, 5, and 6, and y takes on the same values. Find the probability that x is less than or equal to 6 and y is equal to 5. So we fix y equal to 5, and then we use our function for values of x of 4, 5, and 6. We get 3 fractions, added together, simplify them to get 5 21s. The probability distribution of the discrete random variable x is given below. Find the mean. The mean is going to be the expected value, which is the sum from 1 to 3 of x times f of x. So we first find the various function values, and we get these 4 fractions. Now to find the expected value, we take the corresponding x values times the function value, add those up, and we get 1. The random variable x, representing the number of errors per 100 lines of software code, has a probability distribution shown here with an expected value of 3.744. Find the mean of the discrete random variable z equal 3x minus 2. Well, the expected value of z is the expected value of 3x minus 2, which is 3 times the expected value of x minus 2. So we simply plug in what we know for the expected value of x, and we get an expected value of z of 9.232. In a certain district, the need for money to buy drugs is stated as the reason for 45% of all thefts. Find the probability that among the next 5 theft cases reported in this district, exactly 2 resulted from the need for money to buy drugs. So we're going to use the binomial formula here with x is equal to 5 and x is equal to 2, n is equal to 5, and p is our probability of success. In this case, that would be 45% or 0.45. Q then would be 0.55. So when we plug this into our formula, we have 5 choose 2, 0.45 squared, and times 0.55 cubed. We get a probability that x is equal to 2 of 0.337. A scientist inoculates mice one at a time with a disease germ until he finds that 2 have contracted the disease. If the probability of contracting the disease is 1 out of 11, what's the probability that 10 mice are required? Here we're going to use the negative binomial distribution. In other words, the number of the trial on which the kth success occurs is given by this formula. Here we have x is equal to 10, k is equal to 2, p is 1/11th, so q is 10/11ths. Plugging into our formula, we get a probability of 0.0381. The daily amount of coffee in liters dispensed by a machine located in an airport lobby is a random variable x having a continuous uniform distribution with a equal 8 and b equal 11. Find the probability that on a given day the amount of coffee dispensed will be more than 8.2 liters but less than 9.4 liters. The density function that we're going to use here is the uniform distribution. 1 over b minus a for anywhere on the interval from a to b, and 0 elsewhere. In our case, b is 11 and a is 8. So we get a value then of 1/3 over that interval. 8.2 and 9.4 are in that interval. So to find the probability, we simply integrate from 8.2 to 9.4. We take the integral of 1/3 dx, and we get 2/5. Researchers at a reputable university and a reputable health organization claim that approximately 74% of people believe tranquilizers work very well to make a person more calm and relaxed. Of the next 75 people interviewed, what's the probability that at most 56 are of this opinion? Here we're going to use the normal distribution. With a Bernoulli trial, it results in a success with probability p and a failure, probability q, which is 1 minus p. The probability distribution of the binomial random variable is given by this. We saw this in an earlier problem. X has approximately a normal distribution with mean equal to NP and variance equal to NPQ. So the probability that X is less than or equal to X is given by this formula. So what we do is adjust by the factor of 0.5. Here we have a mean of 55.5, a variance of 14.43. That means the standard deviation is the square root of that, which is 3.8. So we're going to standardize our variable with a mean of 55.5 and a standard deviation of 3.8. When we do this, we get the probability that z is less than or equal to 0.26. Now we refer to the standard normal distribution using that z value, and we get a probability of 0.6026. Suppose that the time in hours required to repair a heat pump is a random variable x having a gamma distribution with parameters alpha equal 2 and beta equal 1/2. What's the probability that on the next service call at least 4 hours will be required to repair the heat pump? The density function for a random variable x that has a gamma distribution with parameters alpha greater than 0 and beta greater than 0 is given by this. We have all this information, but one thing to keep in mind is that gamma of n is equal to n minus 1 factorial. To find the probability that x is greater than or equal to 4, we're going to take the complement. We'll take 1 minus the probability of x being less than 4. So the first piece we'll find is the probability of x is less than 4. Plugging everything into the formula and taking the integral, we see that this probability is 0.997. But remember, we're not done. We have to subtract this from 1 to get a probability of 0.003. If the standard deviation of the mean for the sampling distribution of random samples of size 64 from a large or infinite population is 6, how large must the sample size become if the standard deviation is to be reduced to 4.8? So we know for a random sample of size n, the standard deviations of the mean for the sampling distribution is given by this. So we take what we know and solve for the standard deviation. This gives us 48. Now we're going to use that along with 4.8. That's our desired standard deviation to find the necessary sample size. When we plug this in, we find that we need a sample size of 100. A certain type of thread is manufactured with a mean tensile strength of 83.1 kilograms and a standard deviation of 6.3 kilograms. How is the variance of the sample mean changed when the sample size is decreased from 196 to 81? So we use the formula for the standard deviation of the sample mean for each sample size. The first one is 0.45. The second is 0.7. So the variances then would be the squares of those. Notice that the sample variance actually increases when the sample size decreases. Government regulations dictate that for any production process involving a certain toxic chemical, the water in the output of the process must not exceed 7,790 parts per million, or ppms, of the chemical. For a particular process of concern, the water sample was collected by a manufacturer 16 times randomly, and the sample average was 7820 ppms. It's known from historical data that the standard deviation is 100 ppms. What's the probability that the sample average in this experiment would exceed the government limit if the population mean is equal to the limit? Because everything is so large, we can use the central limit theorem. The fact that the normal distribution is symmetric about the mean with a total area under the curve of 1. Because of that, we know that the probability is the probability of the upper half of the distribution is 0.5. A manufacturer of MP3 players conducts a set of comprehensive tests on the electrical functions of its product. All MP3 players must pass all tests prior to being sold. Of a random sample of 700 MP3 players, 14 failed one or more tests. Find a 99% confidence interval for the proportion of the MP3 players from the population that pass all tests. Here we're going to use the normal distribution table. So here's what we need to calculate. And p hat here is x over n. The important thing to point out here is that x is the number of successes. So that's going to be 700 minus 14, or 686 successes. So p hat then would be 0.98, and q hat would be 0.02. When we look at the normal distribution table, for 0.005, we get a z-value of 2.58. Plug everything we have now into our formula for the confidence interval, and we get p between 0.966 and 0.994. A research report claims that mice with an average lifespan of 32 months will live to be about 42 months old when 40% of their calories in their diet are replaced by vitamins and protein. Researchers would like to know if there's any reason to believe that mu is less than 42 if 63 mice that are placed on this diet have an average life of 41 months with a standard deviation of 3.2 months. Identify the null and alternative hypotheses. Now remember, the null hypothesis typically refers to the status quo, whereas the H1, or the alternative hypothesis, typically represents the question to be answered or the theory to be tested. So in this case, our null hypothesis is that the mean stays the same at 42, but the alternative is that it's less than 42. Here we have the grades of a class of 9 students on a midterm report. That's the x value. And on the final exam, those are the y values. We have a linear regression line based on that data that's given here. Estimate the final examination grade of a student who received an 85 on the midterm report. Midterm report is represented by the variable x, so we simply replace x with 85 and solve. We get a predicted value of 77.9. Here we have a study performed on a type of bearing to find the relationship of amount of wear, y, to x1, which is oil viscosity, and load, which would be represented by x2. We want to know the multiple linear regression line is given by this, and we want to know or predict the wear when oil viscosity is 25 and load is 1100. Now, x1 is oil viscosity, so we simply replace that with 25. x2 is the load. We'll replace that with 1100, substitute in and solve to get a predicted value of 148.45. An experiment was conducted in order to determine if cerebral blood flow in human beings can be predicted from arterial oxygen tension. 15 patients participated in the study. To test the hypothesis that beta 2 equals 0 at the 0.05 level of significance against the alternative that it's not 0, the critical region is identified as t is greater than 2.179 or less than negative 2.179. The test statistic is 2.87. What would the conclusion be? Since t equal to 0.87 lies in the critical region, we reject H0. On average, 3 traffic accidents per month occur at a certain intersection. Using the table of Poisson probability sums, what's the probability that fewer than 6 accidents will occur in any given month at this intersection? So the Poisson distribution gives us this. Lambda t in our case is 3. That's mu. What we're going to be interested in is this probability sum. We're going to sum from 0 to 5. I'm going to take p of x with the mean of 3. Looking at a probability distribution, we have mu 3 and r is equal to 5. That gives us a probability then of being less than 6 would be 0.9161. The finished inside diameter of a piston ring is normally distributed with a mean of 12 centimeters and a standard deviation of 0.03 centimeters. Using the standard normal distribution table, find the probability that a piston ring will have an inside diameter between 11.94 and 12.06. So what we're interested in this probability. So we standardize each of those variables based on a mean of 12 and a standard deviation of 0.03. This gives us a probability that z is between -2 and 2. This is equivalent to the probability of z being less than 2 minus the probability z is less than -2. So pulling up these portions of the probability table, we can see then that our probabilities are, for probability of z is less than 2 is 0.9772, and the probability z is less than -2 is 0.0228. Subtracting these two, we get a probability of 0.9544. The mean score for freshmen on an aptitude test at a certain college is 550, with a standard deviation of 70. Assume the means to be measured to any degree of accuracy. What is the probability that two groups selected at random consisting of 72 and 70 students, respectively, will differ in their mean scores by more than 17 points? Here we're going to use the normal distribution again. So to standardize in this case, what we're going to do is we're going to use this formula. Now, the probability that the mean scores differ by more than 17 points is given by this. So we have the probability that the difference is less than -17 plus the probability the difference is greater than +17, which because of the symmetry of the distribution is 2 times the probability that the difference is less than -17. So when we plug all this into the formula, we get a z value of -1.45. Referring to our standard normal distribution table, we can see then the probability here that z is less than -1.45 is 0.0735. Multiplying that by 2, we get a probability of 0.1470. A random sample of 23 chocolate energy bars of a certain brand has on average 210 calories per bar, with a standard deviation of 25 calories. Assume that the distribution of the calorie content is approximately normal. Construct a 95% confidence interval for the standard deviation, and we're going to refer to the chi-squared distribution. So here's what we know. If S squared is the variance of a random sample of size n, what we have is a 100 times 1 minus alpha % confidence interval for sigma squared, or the variance of the population, can be found by using technology, or we can use this formula here. So in our case, we have n is equal to 23, s is 25, that means s squared is 625. Alpha is 0.05, so alpha over 2 is 0.025. The degrees of freedom would be 23 minus 1, which is 22. So, chi-squared, in this case, would be 10.982. And chi-squared for the other end would be 36.781. So, what we have then for our confidence interval, going back to our formula, plugging everything in now that we have the chi-squared values, and simplifying this, we then get that sigma squared is between 373.834 and 1252.049. Taking square roots, we get that sigma is between 19.33 and 35.38. At a certain college, it's estimated that at most 34% of the students ride bicycles to class. Researchers want to determine if this seems to be a valid estimate if, in a random sample of 96 college students, 38 were found to ride bicycles to class. We're going to use a 0.05 level of significance to find the test statistic, and we're going to be using the normal distribution. So first we're going to make note of what we're given. P naught is 0.34, Q naught is 0.66, and N is equal to 96. To standardize this, we use this formula. Z is equal to X minus N times P naught divided by the square root of N times P naught times Q naught. Now it's a matter of simply substituting everything in. We see that Z is equal to 1.15. Compute the correlation coefficient for the following grades of 6 students selected at random. So remember, this is a big, ugly mess. This is the formula that we use to calculate the correlation coefficient. SXY divided by the square root of the product of SXX and SYY. So, and these are the formulas for each of those individual pieces. So, first of all, we have to calculate X bar and Y bar. And the value for X bar is 77.33, Y bar is 79.67. Recommendation here would be to use technology, perhaps a graphing calculator, or Excel, or something along those lines, to calculate these values for our sums, because they are quite tedious to do. When you do so, you should get these various values that are needed for the formula. The last step then is to take everything we know now, put it into the formula, and we get a correlation coefficient of 0.339.